All right. I will just start. Event sourcing from the trenches. Yeah. Okay. There's another question because maybe the examples are not really relevant. Any .NET developers here? Couple. Oh, I didn't expect that. The rest is Java, JavaScript, PHP, Python, Go, Erlang, Elm, all this stuff. Anyway, so yeah, let's start. It's pretty loud, by the way, the sound. I'm not sure if it's about you, but I found it very loud. I can hear myself, and I don't like that. From the trenches. So I think I first got the introduction from Greg Young, like in 2009, together with some other people which are pretty well known in the DDD community. And in 2012, I found an opportunity, let's call it a client, that's to, take this architecture style? No, of course not. There were good reasons for that. I mean, I'm a consultant. I don't introduce fancy stuff just for the fun of it. But no. So I've been designing, maintaining together with a group of people since 2012. So I felt all the pain, and I did a couple of talks over the last years about what is event sourcing, what is the good, the bad, the ugly, and that kind of stuff. And then at some point I thought like, okay, I can maybe complain about it, but maybe show also some examples of how you can actually benefit from that. It's a difficult topic. If you do not completely follow it, just approach me afterwards. I will be around. I heard there's some drinks and beer, so I'll stick around. I'm Dutch. It's free. So yeah, who am I? This is me, big picture. I call myself the continuous improver because I like to improve myself, learn languages. No, but I'm continuously looking for better tools, architectures, way to work with people, with teams, product owners and that kind of stuff. And that's my Twitter handler, and I have a motto which is like, I'm on an everlasting quest. I read a book, and the book said, as a professional software developer, you need to have like a motto. So I came up with a motto. This is my motto. Always looking for new things to learn. All right, let's do a bit of, by the way, I have a blog, and I have a couple of open source projects. Maybe you've heard of some of them. Let's do a little bit of an introduction of event sourcing. And again, if you're not in the .NET space, it doesn't matter. It's just extra information in case you care about this stuff. But let's just try to explain a little bit like what does it look like in a technical aspect. So imagine I have an application. We have an application. The application sends a command. In this case, it's the correct customer email command. And it's a crappy name because correct doesn't say much, although you can reason or debate that it could actually be from the language that the business follows. I have to be careful not to be in the light. So we don't say like we update the customer email, we actually correct it. We try to capture what we try to do. If you're in the DDD world, you know this stuff. You follow the ubiquitous language. This word which is so difficult to pronounce. How do you say this in French, just for the fun of it? Ubiquitous, just with a French accent. Ubiquitous. Sorry, couldn't resist myself. Anyway, the command is sent into something that we can call a command service. Then it will look for something like, I don't know, something that understands how to handle the command. So the command service is more like an entry point, could be an HTTP endpoint, could be some kind of bus endpoint, but in the end, it needs to find a place or somewhere that understands what it means from a functional perspective to correct the email address of a customer. Then it will actually talk to something called, can you actually see this from the back? Because the resolution is not that high. It's something called the unit of work. You probably know this. It's a design pattern, and we all know design patterns here, looking at the experience in this room, which eventually will go into the event store and load the entire history of that particular customer from the event store. And the event store is essentially nothing like a flat table that contains everything that ever happened to this customer. This is returned, and at that point, and this is a disposition, we actually create an object. Whether it's Java, .NET, or the other language, at that point, we create a thing in memory that represents the customer, and then initialize it using all the history that was there. So at that point, we actually capture, or let's say we call it dehydrate, I think it's a fancy word, where we say like, okay, we have an event from the past that the customers were enrolled. I mean, customers they're not created, they're enrolled, hopefully. They're also not deleted, they just decide to part ways with you. But there might be information like the customer Rating has been increased, and now it's like a gold platinum customer, and it can have more outstanding orders. All this information is captured in the event store. So it's not like what you see traditionally. You directly load the thing from a record. There's a table called customers, and there's records in there. You just load that record into memory using maybe something like an object relational mapper, or maybe using a document database. No, you actually load the things that happened to that user from its initial enrollment in the organization. Now, what else? You apply a command like correct email. At that point, it will check, is the email actually changed? I mean, if you don't change anything, what's the point of storing this information? And at the end, the command service will send a message back to the unit of work, like now, figure out what has actually changed in this particular little session that happened, and send that back into the event store. Well, there's a problem here. You can't really query on this database, right? Actually, this is the right side of the architecture, and it's also the right database, and yeah. So you need something else. So we introduced something what we call a projector. And a projector is responsible for taking this history of things and projecting it in a way that makes sense to whatever you need with the information. If you want to be able to read the information or display a list of all, like a count, a number of customers per region, you can actually project that in a table or in some kind of storage that's already optimized for querying it. So the projector is kind of to deal with the fact that we have two worlds. And it can be some kind of data access layer, and it goes in a read database, and that can be a relational database. It can be like something like a document database, whatever you want. Could even be an HTML document or JSON. You project directly to a JSON document, so when the HTTP request comes in, the data is already pre-generated. So this separation, does this ring a bell? Architecture style? CQRS, of course. And that's why these two worlds work so well together. They're two different things. CQRS is about separating the fact that you have a domain and the read side, so separating those things that always have a lot of friction. Event sourcing just changed the way how you store this information. Does this make sense? Is this for who is this not new? Just to check. Okay, so I have chosen the wrong presentation actually. So this may be interesting. For the .NET space, there's a couple of balloons. I'll put this all on the internet. You can see like what are the libraries available. There's a couple of stuff for the event store. So for different aspects, there are different libraries. Yeah, this kind of it. So let's dive into the trenches. The first thing, and that's really a big misconception, is that you need to understand boundaries. Any DDD practitioners here? Bounded context? No? It's just a boundary. Let's say we have a couple of domains within the application, so it's not one big monolith. Of course, it's a monolith, but at least you create some kind of like a nice PowerPoint picture where you identify the boundaries, then it looks like a real nice architecture. Whether it's internally built like that is not really relevant, but you have a drafting domain. Would you use events? Okay, and by the way, a drafting domain is the domain where you, in this particular case, would write up legal documents. Would you use event sourcing for drafting a legal document? Who thinks you need event sourcing for that? Raise your hand. It's a flat table. Yes, it can be anything, but it's anything that allows you to associate or store the events for a particular object in order of occurrence. So it can be anything. It can be a SQL table with a single table, basically, with a couple of columns, and usually there's something called a stream ID, which identifies the objects. But if there are any of these questions are lingering, just approach me later on. I can show you some more details, because then I need to find some kind of balance in terms of availability. But just understand the drafting domain. So drafting domain, indeed, the question is, should we use event sourcing here? A policy execution domain, which is like we take this legal document, because we've done our DDD thing, we've identified the different people involved in this process, and came to the conclusion we're actually dealing with the same legal document with different people working on that. Drafting is probably done by the clerk. But actually setting all the signatures that you need to do, it's a different division or different people with different authorities. So this is the domain where the legal document is executed and all the things that are mentioned there are actually applied in real life, which has to be signed off, for instance. And then you have the search domain. So where would you use event sourcing with what I just heard? Drafting? So yeah, actually I would use a really simple CRUD-based architecture for drafting. Because in the drafting phase, I don't really care about who changed what. Usually it's one person anyway that does it. So why would you use an architecture style that doesn't fit there? Yeah, maybe because it's cool or you have not done it before, but that's a big mistake. I will use something simple. Maybe an ORM or maybe some kind of document database and you don't need ORMs anymore. I don't know, React front end. Traditional CRUD architecture. This one, I would use event sourcing, and that's why you see things like projectors and this stuff, because this is the phase where this document is actually executed, where we need to track exactly who set which signature at which point in time. How did this document actually became active, and what happened over the lifetime of the document? Was it amended? Were things changed, regulations changed? This is where it could actually shine. It's also the part of the domain where potentially multiple people are touching this thing at the same time. So event sourcing is not like, it's for me, it's actually just a tool. Yeah, with every tool, I think it all comes down to understanding when a tool needs to be used and when not. What are the advantages? When it's a bad thing to use. Search domain, event sourcing. Well, you know, one cool thing you can do, is to build projections which are optimized for searching. So you could technically, and especially if you use a specific storage technique there, you can build a projection that's completely optimized for searching. So technically, you could, and it will work, but I wouldn't do it because I would actually use something like maybe some kind of indexing-based architecture using Lucene or Elasticsearch, because that's built for that purpose. And again, it's all about finding the right tool for the right job at the right time. You can remember that one. The rest is not important. So, oh yeah, maybe some kind of bus, you know, to have them communicate with each other. Maybe some webhooks to connect them together. Yeah, some coarse-grained HTTP requests between the different aspects, even though they all live in the same architecture, even in the same application. I mean, if you're thinking about, oh, are these microservices? Could be, if you need that, but it doesn't have to be. It's all about choices. However, what's important, and maybe that's forgot to mention, so event sourcing is not a top-level architecture style. It's an architecture style that lives within the different domains. Different domains need different solutions. This is the mistake I made, and Greg Young told me like 10 years ago, but I was stubborn, like all developers in general are, specific ones. So remember that, it's not a top-level architecture. So let's go inside the domain. We have this shipping domain. This is another example. We have the application sends a correct customer shipping address. So we figured out, or customers figured out that we've kept the wrong shipping address for them in our system. So we need to fix that. So what happens, we send this command, correct customer shipping address, to this command handler that I just explained to you, which will find the customer. In this case, it has identity 123. We apply the new address, which results in an event. Events are usually quite often one-to-one with the command, but then written in the past tense. Now in this case, it's the shipping address corrected event, which we store in the event store. Are we done then? So we have a customer, we change the shipping address. What could possibly go wrong? Correct. So we actually have an open order that is already scheduled to be shipped. Well, I wouldn't go as far as the packet's already gone, because that's problematic, but you can expect that, yeah, you know what? We need to fix the shipping address of an existing order because it's changed. So we use the same event within the same domain to have something respond to this. And in this case, we find order 456 and change its shipping address. Basically, we redirect it. Like as a developer, we talk about, we change the shipping address of the order. No, that's how we as developer talk. But if you ask the business, they say, no, that we redirected the order. Again, the ubiquitous language, or the ubiquitous language. What else? Yeah, there's a couple of notes. A command, for me, is a message. So it should be like only using primitive types. It's something you want to be able to send over an HTTP request, over some bus. I don't know what kind of buses you use, but it needs to be something that doesn't capture any business rules. It's just a message that you want to do something. It's a pretty directive message. That's what a command is, but keep it simple. Customers, they have like a key, in this case 1, 2, 3. One of the things I'm really careful about is to try to identify a partition key. If you have a big event store, eventually your event store will become so big, it becomes unmanageable. So being able from the start to already identify like certain aspects of it can serve as a natural partition key. Maybe your customers are all organized in specific regions. Because if your event store becomes really big, and it can become millions and millions of events, you want to be able to split it, like partition it. If there's a natural partition key where there's no business rules across, then I would identify it. The other thing is don't expose your domain outside the actual bounded context. See it as a boundary. See it as a kind of a way to isolate inside your architecture. Whether you build a monolith or microservice, it doesn't matter. See it as a separate thing. And the other thing is, don't use the identity, or especially like if it has a natural key, like a username. If you have an Active Directory user, you have the username. Mine is Dennis D. Don't use that as an identity. Because I don't know if you've noticed this, but usernames in Active Directory can change. And if you use this thing to identify it all over your system and it changes, you've kind of, can't say that, probably would say merde or something like that, or putain. That's what I remembered from 20 years ago. That's the only French I still know. So yeah, be careful of that. Try to find something that's really uniquely, which is unique, which will stay unique whatever happens with that object. That can be difficult, by the way, because it's really feels logical to take the natural key of something. Another thing is, which I also did, is to try to avoid like events that just represent that a property has changed, the address has changed, the title of the order has changed, the title of the product has changed. Try to capture what happens, make it functional. And again, sometimes it means you need to talk to your product owner. Yes, you need to talk to your product owner, even though you don't want to, because he or she always changes the requirements, but it's really good to talk about that. Yeah, and again, here, same thing, use primitive types only. We thought we were smart, like we have this ISBN number for books. We created a nice type for that encapsulates the rules for an ISBN number. You put that in your event. This event is stored in the event store, and then 3 years later, you try to load, this existing product from your event store, and boom, it exploded. What was the problem? The rules for an ISBN number have changed. So the type that I have in my code base only understands the new rules. It didn't understand the old rules, and it didn't know that an ISBN number used to be bigger or something, or has a different format. And then you cannot even load the data from your system. It's kind of a rookie mistake, but yeah, I've made it. What else? Yeah, don't use those events either also outside. I mean, I've already mentioned you shouldn't use your domain outside your context or your boundary. Don't expose the events, because that's really going to hurt. Again, it feels so natural. I have this nice stream of events of what happened in my domain, and I have the other parts of the system that want to subscribe to that. They want to be we're notified. Let's just reuse them. It's like a leaky abstraction, and we don't like that, leaky abstractions. So try to think of different ways of doing that. And finally, yeah, I already mentioned it, don't use terms like create, update, delete, and change. I mean, that's us developers. So another example is the shipping domain again. I have an application, sends this command, loads the customer, address is corrected. The same one as just a second ago. Now the question is, this specific action from the outside affects 2 different entities or objects in your domain. How do you deal with that? Do you do this in a single transaction? What happens if the first one succeeds and the second one fails? If you go puristic, what happens? Oh, it's weird. If you go puristic, you actually do this in a transaction. So you first update the customer, put this in a database, commit it, and then you do the second part. Oh, something went wrong with the presentation. Oh yeah, this is the second part. So you still have the same action, but the customer's persisted and then you take the order. Or do you put everything in the same transaction? Like this. That's perfectly fine, actually. But if you really want to be high performance, and if you read the books are pretty, let's say, puristic in that sense. They say never touch more entities, or they call it aggregates in the DDD term, more than one aggregate in the same transaction. Yeah, that's probably the best way to do it, but it also introduces complexities. Because, you know, let's say this succeeds, and you do this in a transaction, then you try to do this, and this fails. Then what? You can undo the other one, but yeah, it's already happening. So you have to roll back the transaction? Well, you can't. So you have to do compensation. And you can't do that if it's really likely that different people or different users are touching the customer and the order at the same time, and this becomes like a contention point, a bottleneck in your system in terms of performance. You can't do that. But you need to do it because it adds value, not because a book tells you to do it like that. It's a trade-off again. If you need the performance, yeah, build the infrastructure to retry this stuff or add compensating transactions. But it adds a lot of complexity. Versioning is another aspect that's really complicated or really annoying, actually. So as an example, I have the same command service. There's some command handler, loads a customer with identity 123. There used to be an event called customer created. Well, we all know customers are not created. We don't create customers. If we could, we would all be very rich, right? Yeah. At least I can't think of a way of creating a customer. But we may want to enroll a customer. So this was obviously the naive developer said, oh, okay, customer, I need to create a customer. Okay, customer created event, done. You know, but again, ubiquitous language is identifying the language of the business for a particular domain and being extremely aggressive, being extremely consistent that the rest of the code base follows that. I mean, I wasn't going to say be aggressive to your product owner. So you might decide over time, because code bases change, to change the name of the thing, to rename the event. However, you cannot change the past. At least I can't. There's lots of things I would do differently. So what you have is something like, we call the event converter. Sometimes they're also called up converter. I've heard people use the name upcaster or something like that. But what we do is when this event is loaded from the event store, we have a converter that understands how to change this thing into something, into an enrolled event, this one. So it converts it. And actually, this thing may do a couple of things. It may actually split or merge an event. This happens quite often. You choose a big event, like it was too granular, you decide to split it in smaller pieces. You may want to change the identity, like we had the username instead of the Active Directory, SUID, like a GUID. It can try to fix that for you. If you fix it at runtime, it means you need to keep that code, all these conversion code, until the end of days. We've done that, it's pretty okay, but another product that I worked with actually decided to run this during the migration. So when you go from one version to the other, you process all the old event into a new version. If that's acceptable, yeah, that can work. I would probably keep some record, because if you want to go into the event store, like what happened with the old events, maybe some record that something got removed or split or something like that for historical purposes, especially if you need to be SOX compliant, but it's an option. And then this new event is loaded into the customer, or actually it creates a custom object. That is a valid thing. Using the event, and then the rest of the events are loaded in that. And then you continue as you went before. This stuff is always painful. Everybody's struggling with that. So what about projections? There's a lot of things to say about projections. Event store, a couple of projections here. What do we have? We have a projector using a relational database, or two of them, and I have a projector with a document database, and they also subscribe to the same event store. One thing that's important is that a projector, in my opinion at least, because that's the mistake I've made, they should be autonomous and independent. It's kind of pleonasm, I think, or yeah. Autonomous as in it can decide when it needs to be rebuilt, because code changes. Bugs are introduced. You want to be able to say, I want to rebuild this projection because it needs a different structure, maybe in a different version. Independent is that you want to be able to have one go faster than the other, because the projector is about taking this entire event store, processing every event, and creating this structure that you need. And this will change over time. You might decide to use different storage techniques, and it's already mentioned here, like a document database here and a relational database there. They subscribe to that and start the process. This should be optimized for whatever it represents, as I said earlier. This could be a database, but it could also be, as I said earlier, an HTML or a JSON document. Use whatever is fastest for that particular projection. You can even build up the projection in memory. We've done that. We have temporal projections that do that. You can even have like a caching strategy. You know, like maybe this information can be cached aggressively because the information doesn't change that often. But again, that means that the projection should be autonomous. It should be able to decide without having any dependencies on other projections. And this is really difficult because it requires discipline. It's really natural for a lot of developers to take, especially if there's a SQL table behind that, just join some tables during querying. But if they are not going to be built at the same pace, it's going to hurt you in the end. You could have a lookup, but you need to make sure that the lookup is owned by a projector. Let's say you have a list of country codes and all the information for a country, and that you need this information to build this particular projection. You need to be careful to not reuse this thing, because it's owned, it's maintained. This projector is going to subscribe to all the events related to the country information or geographical information or something, and needs to maintain because this one needs to be in sync. Again, it's really tempting to reuse that thing. Don't. By the way, when I say don't, what I really mean is I advise you not to do this. You can still do it because we're all stubborn, and it might be fine. And if it's not fine, if it's going to hurt you, remember my talk. I'm known to be sometimes, I can appear a bit dogmatic, which is not true. At least I don't think I'm dogmatic. What else? Okay, I already mentioned this. You shouldn't reuse the projections. Well, actually, there's two aspects to it. Is that, and that's the other thing, is the joining part. Don't join them, but also don't reuse them for different things. I've seen that. I have this projection. I've spent a considerable amount of time to actually build this thing. Now I need one extra property in a different part of the system, and the data is already there. Why can't I just query that table? Again, that's a trade-off. If you do it too often, you end up with this mega thing full of generic properties used everywhere, and then you're kind of stuck, because if two parts of a system have different requirements in terms of availability of this data, this can change. You create this coupling, and it becomes really difficult to optimize for one case if you do not understand the other case. Again, it's a trade-off. Projection in .NET, I will just quickly show you an example what it looks like in a .NET space. It's something like this. It's a map builder, and then you have a kind of a Fluent API to map the events to each other. You can say something like you should only do this when, like this one is an example, like if the state of a legal oh, you don't see anything actually. Hey, oh, you can. This one is an example that will say if a legal document is closed, I don't even care about it anymore. I don't want to project that. That is a performance improvement. Now, there's another aspect to it. Who's using ORMs, like object relational mappers in their code base? Yeah. Who actually objects them, hates them, think they're a bad thing to do? Some people think, yeah. No, it's fine, it's fine. You know this hype cycle thing? You first love something, you become really enthusiastic about it, then it starts to hurt, you know? And then you start to reject it, and you do talks about that you reject this thing. It's a really, don't do TDD. It leads to really small, unrefactorable code bases. Well, there's some point where you start to learn, like find the sweet spot, where it works, where it doesn't work. Same with ORMs. Because consider this. I have 6 events. They're grouped into functional transactions. Let's call it like that. The database, and I'm going to execute insert statements. So every time an event comes in, the projector has to take that event. It has to update the projection. Let's say those 6 events all apply to the same row in a table. Let's say, for the sake of the simplicity, assume there's a SQL database. Those are going to be 6 update statements, or 1 insert and a couple of updates, right? That's 6 SQL statements. Usually, your SQL database is not on the same machine where your code is running. At least I hope not, because we're all in the cloud these days. So there's network latency. And the network latency is always like, I don't know, 1 millisecond or something. Or You take this approach. You use an ORM. The ORM will process those 6 events, and at the end, we'll execute one insert statement, or maybe a couple of insert statements and update statements in one SQL state. You can group statements here like that. What do you think is faster, left or right? It depends. That's a good answer. Yes, that's true. So if your projection has the tendency where a lot of events related to the same object are usually pretty close to each other, the right side is definitely faster. I can tell you that. We had an upgrade process that took 20 days for a certain French client, which I'm not going to disclose. When we introduced this again, because some architect which rejected ORMs ripped all this code out of the existing code base, we reintroduced it, and suddenly it was 2 hours, from 20 days to 2 hours, just because of the fast number of insert statements. However, just like any tool, for some projections this works, for the other ones it doesn't work, and that's the reason why I told you is that every projector needs to be autonomous. You need to be able to say, for this particular thing, to really get the speed I want to use an ORM. Or I even want to use a document database. I want to do this in memory. I use aggressive caching. But for the other one, maybe raw SQL is the fastest way. Again, it depends. Good answer. You've paid attention. Yeah. And why? Because an ORM has a unit of work. So the ORM does not have to solve the impedance mismatch between your object model and your relational model. No, because it's probably a one-to-one mapping, but this unit of work is what the power comes from. It's the thing that allows you to load an object into memory, apply change, and at the end to say, flush it back to the database in an efficient way. And even the old ones, like if you're in a .NET space, you may remember an Hibernate or a Java Hibernate. It's really advanced. Has a lot of intelligence in there, like I can group, I can batch update statements, I do all kinds of smart things which will make it really fast, and that's what we're trying to do. Yeah, but there's some setbacks here, is that what happens if there's an exception somewhere? Because exceptions and projections that fail, is the most common problem in event sourcing. Like your column is not big enough. Here on the left side, I want to jump over the light. On the left side, you actually get the exceptions after the insert statement. On the right side, you do not get that. Basically, you apply a whole bunch of changes. You execute one update statement to the SQL database. If something, and could even be multiple projections at the same time, you just get an exception. You don't know which one is causing the problem. Well, as an example, we can do something like this. What does this do? Is an example of a bit of code. It first verifies if an exception happens while accessing the database. Is this a transient thing? They happen, transients, exceptions. You need to think about the difference. Transients could be a timeout, or the database is temporarily unavailable. If that happens, what I'm doing here is, if it's the first 3 attempts, I'll just retry. This is an example of a little library that I've built. But if it's not a transient exception, then I'm going to say, you know what, I have this like 1,000 of events that I processed all in memory, flushed to the database. I'm going to break it up in small pieces until the one that fails actually raise an exception. Everything before this point is then resolved or committed to the database, so I can trace down exactly which one is going wrong. These are some of the techniques that you can use for that. Enriching event is like I mentioned the lookup earlier. Well, let's say you have a way to say that I need to have this country information available in different places. What you can do is I have an enrichment projector which is subscribed to the event store, which has some kind of potentially persistent cache. He's going to show me I have 15 minutes left, I know, yeah, 13 actually. I have another projector that subscribes to the event store like it normally does. But there's something in the middle, which we call an enricher, that will look at the events from the event store and add additional information. Like, you know, you have this this country code in your event. A legal document was issued, valid in a particular country, but you want to have all the other information as well. It just emits basically another event that extends or adds the country information, like the country name and, like departments that you need to contact that are required authorities and stuff. That's a really nice way to speed up this whole process. Again, you don't have to do this, but it's an option. And that is then stored in the database. Yeah. Another thing is tracking progress. There's an example you can look it up later on, is how every projector keeps track of what it's doing, and especially how it keeps track of how long it will take to have this projector catch up. Because one of the things I didn't mention is that if you really want to have your system up and running quickly after an upgrade, like a new version, you can decide to make your projection asynchronously. So if it's a projection that contains information like search results, if you don't want to use Lucene, that doesn't have to be immediately available after the upgrade. You can let it run in the background, and then you can track progress, like how fast can it actually project all the information, and give you some calculations, like the ETA is like 1 minute behind. And you can use this in your user interface to provide some information, like, this data is right now being indexed, or please wait, hold a moment for the index to be updated. These are options that allow you to solve some of these problems. This is an example, like you can calculate the speed. This particular library does that for you, even provides an HTTP endpoint for the .NET stuff. And you can actually then go to the HTTP endpoint to get this information, and your beautiful React, Vue.js, whatever front-end technology you use, you can use this information there. One other problem that happens with event sourcing is that at some point there's so much events, so much data. If you then upgrade to a newer version, the more common approach is to rebuild all your projections. It will just become too much. There will be millions of events. Like our biggest client that uses the event source system has like 160 million events. And they all have to be projected into all these tables again. I can tell you what's the bottleneck: SQL Server. For anybody using Oracle? I'm not going to make jokes about Oracle. So there's a concept what we call archivability. Works like this. I have a graph projector, and the graph projector has task is to figure out dependencies between documents. Let's say one legal document cannot be issued until the other legal document is issued because there's a dependency. Even lawyers break down complicated problems in small pieces. It tracks the dependencies. So let's say document 1 is created. We wrote the document, but we do create documents. Then some other stuff happens, and the document is closed, or maybe the document is like shredded. The graph projector tracks all this stuff together. So what the graph projector do at the end, it will actually say, I'm going to load document 1 from the event store and mark it as archivable. I'm going to tell the document, you're going to be archived soon. It's still available, but maybe in 90 days, we're actually going to get rid of that. That is an event on itself. So the fact that we say this document is going to be archived is something we capture in the domain and use that because we store it in the event store. Which means a projector that has actually active projections referring to those documents knows, okay, you know what? This document is closed, has been marked as archivable, I can just delete the data. Which doesn't really help with the original problem, but it does keep your database like to a minimum, because it depends a bit on your domain, but it's very likely that the number of active documents is pretty limited at any point of time, because the majority is just closed. In fact, you could have an archiving projector that at some point says, I'm going to actually mark the events as archived. So I've added an extra bit of metadata to my event store, so I can see from the event store that these events represent or are the things that are part of documents that are archived, or going to be archived. Which means that if this thing has to rebuild its projection after like a new version, or because there's a bug, it can actually skip all those old events because it's already clear. It's going to be archived. I don't even have to project that, which brings down the number of events to project significantly. But you can go further. You can do tombstoning. Like the application, same thing. We have a special projector. We have this event from earlier, marked as archivable event. And then the Lucene projector will take a snapshot of this document from the event store, loads the actual thing, as I just explained, and puts that in a Lucene index. So we're projecting into an insearchable index. Then the projector will tell the document to tombstone, which means the document will actually remove its history from the event store. Again, it's not always applicable, but it's an option. We probably keep track of that, yeah, and that's it. And then it's gone. And then there's a document projector for the active stuff, which actually understands all this stuff, so you can provide information about cleaning up. So the original projector will remove all the projections that are no longer relevant because there's a snapshot in Lucene, and you back up this index. the sound. Oh. And then at the end, your application just searches like into the things at the same time. Make sense? This is something we use to really solve the big problem because data just became bigger, bigger, bigger. And we make it faster with ORMs, with all kinds of smart stuff. Data keeps growing. It's inevitable. And this was a really nice way of solving this. Now, another thing, upgrades. Yeah, you can do this. I have an application which is version 1. It has its own projector and it creates its own schema. You can do something like remove version 1 of the projection table, create a new schema in version 2, and then let the projector itself build up the new schema side by side. That's one way of doing it. However, it does mean if you upgrade from your product from one version to the other, that you have a bit of downtime. Because, yeah, until this is updated, the system will not be available. And again, some of the scenarios that I showed earlier, you can use to make it a bit faster. Again, the tombstoning will help here as well, or even archivability. Another is like a blue-green deployment. You have version 1 of the application and version 2. There's a network load balancer in between, and both applications are reachable at the same time. Now, what happens? Version 2 will return 503, which means the load balancer will reject or will basically route all the incoming requests to version 1. Right? This is the way it works. And you can do this completely automatic. Then, version 2 is going to copy all the events from the left side into the new version, project it on itself, because, yeah, it has its own deployment, its own database structure, especially if you use like local document databases. This is really efficient. Until this whole process is done, and in the meantime, version 1 just keeps running. People can use the system because version 2 will just, initially there's a whole bunch of data to copy and just keep up to date, like at the last point, until it tells version 1, I'm going to bring you offline because I'm up to date now. I know I've been catching up with you and I'm mostly a couple of seconds behind. Then version 1 say, okay, now I'm unavailable. So for that fraction of a time, both of them are unavailable and you have like perceived downtime. And then version 2 said, hello, here I am, welcome in the new version of our product. And it completely works smoothly and automatically. Does that make sense? And these are really cool things that we've done actually in production. This works really like we have auto-scaling group in Amazon. So when a new version is rolled out, we basically just spin up an AMI, if you know what it is, like an ISO image, which spins up a couple of machines, and this whole process starts, and if it crashes, it just continues where it left off. And at the end, the users don't even notice that. Yeah, worst case, the actual save request or something gets like an error rate, like the system is not available temporarily, but within a second, it's already available. And that's the best way to do it, in my opinion. Some of the examples that you saw were actually called liquid projections. There's a library that I built as part of some of the effort. Yes? Is the event store shared between version 1 and version 2? It's possible. You can do that. So if you could actually choose to say, I'm going to use the same event store on 2 places, but in this case, I usually also do the migration where we do all the upconversion of events. So they both have their own event store. Version 1 contains the original one. Version 2 will contain a copy of that, plus all the upconversions that we executed. But you have options, like we also have like blobs, PDFs and attachments. We reuse that database because it takes just too much time to copy over all this data. Again, if you're in .NET space, you can look it up. There's all kinds of little building blocks that you're supposed to use. Yeah, this was the in-depth version. I hope it was deep enough for you guys. I see some people like, I'm falling asleep, yeah. I hope it was not because of my talk, but because of the heat here in this room, or too much beers last night. But yeah, I will be around for questions. Time is up. And let me know if you have any additional questions. We have still 2 minutes, by the way, if you want to. Yes? Just to know if you can share the slides of your I'll project my slide into the internet for you. Yes. Yeah, it's already there, actually. I didn't want to tell you, otherwise people don't come to the talk. Yeah.
You said that we don't need to use the intra-domain events, but how
Do you share information? Yeah. So the question is, I've been saying that you shouldn't reuse the events from one domain into other domains. What we typically do, we create more coarse-grained events. So we project the small events into more bigger events that represents actual business cases, and we expose that as webhooks to the other components, either in process or out of process. And .NET, you have really cool tools to create HTTP components that all hosted in the same process in a transparent way. That's how I prefer to do it. But we actually shared some events for a while until it started to hurt. Again, there's maybe a good general answer is that not all of these decisions you have to make up front. It's all about figuring out how painful is it going to be if you change your mind afterwards. If it's not going to really make a big difference, just choose something that works for you right now and later introduce this anti-corruption layer. Because if you don't, you end up with really, an obfuscated number of abstractions, and it's not going to make your code base really clean to understand. Does it answer your question? Time's up. Thank you for your attention.